Good afternoon, everyone. Welcome to the CleanTech Spotlight webinar series. I just wanted to welcome everyone. Sorry we had to start a few minutes late. There was a little bit of a initial login issue on my end from MassCEC, but we are all here and we are excited to feature one of the MassCEC CleanTech Spotlight grantees, InRoof Solar. We have a few folks from the InRoof Solar team on the line who will run through their project. Just as a quick kind of housekeeping note, all of the attendees are in listen only mode, so you will not be able to verbally speak, but if you have any questions or anything throughout the presentation, you are welcome to submit those into the questions box in the webinar feature. We will have InRoof go through their presentation, and then at the end, we will allow questions from the audience, and that's when we'll kind of triage the questions you all submit in that questions box. InRoof Solar is here to talk about their innovative solar thermal heating and cooling technology. As you can tell from the name, it obviously has to do with the roof, but I won't steal the light from them, and I will kick things off to them.
Okay, can you hear me all right?
We can, I can, yes.
Okay, and I guess with this presentation, who's controlling the slides? I see the presentation, but I'm not sure I've got the ability to
Oh,
do slides.
right, yes, I am controlling the slides. So whenever you're ready for me to advance to the next slide, just say next slide and I'll click over.
Okay, well, I'll just start with some introductions. This slide is sufficient for that. My name is John Delmar. I'm an engineer. I've been working with InRoof Solar for 5 years or so, probably. We also have Bill. Well, maybe we should just each introduce ourselves. Fred and Bill, you want to introduce yourselves?
Sure, yes. I'm Fred Harkness, founder of the company. Been working on this for many, many years, and this is something that's kind of coming to fruition after a long period of time. We're really starting to get work now. We're really happy about it. Bill has recently joined our group as a sales manager and is starting to network out to other salespeople. And despite the economy, still seems to be having some success, which is very exciting. So, Bill, maybe you want to speak to your situation?
Sure, thanks, Fred. Good afternoon, everybody. Yeah, as Fred said, I just joined the group to help out with sales. We're talking to people literally around the country now and setting up a sales network. And as Fred and John alluded to, there's some pretty interesting and exciting things going on in terms of how we can help with making buildings more energy efficient and working through the cost-benefit analysis on that. So the timing for this presentation is good, and we really appreciate the support from the MassCEC.
Okay, well, great. Yeah, I guess I will basically sort of lead the presentation, but Bill and Fred are basically invited to, comment and add more detail at any time. So now you know the voices. Go ahead, and you can go to the next slide. Okay, so we've introduced ourselves as a solar energy company. Basically, we're addressing a very similar problem to most renewable energy companies, looking at increases in energy prices, increases in CO2 emissions. One area where we sort of specialize is the aesthetic aspect of most solar projects is sometimes an issue, what they look like on the roof, and we've basically integrated it into the roof. So the aesthetics is not a concern with InRoof Solar projects. We also have a very high quality roof product. It addresses, a myriad of roof issues that may occur with lower quality roofs. So our product is something that is very high quality, built to last. as a roof as well as a renewable energy product. And of course, it addresses construction waste. Basically, we're taking existing materials that would be part of a building anyway, and we're adding additional functionality to them. We're basically taking the envelope, in particular the roof of the building, and giving it a very specific renewable energy purpose. Next slide, please. So what we have is a solar thermal product. It's built into aluminum metal roof. The roofing product is the same commercial roofing product that roofers all over the country already know and install. Basically, we take those standard roofing materials and add an additional solar thermal collector to the underside of the roof. So what you see from the outside is just a metal roof. Everything that we do is on the underside, invisible to the observer from the outside. You can go to the next slide. Okay, so normally for projects with solar, photovoltaics are very much what everyone thinks about when they think about solar. So we usually introduce what is solar thermal, even though it's by far the older technology. The recent sort of surge in photovoltaics has made that the one that everyone understands and knows. So I just lost view of the slide. I don't know if that was on my side or not.
Yeah, I lost it too.
Is that something that happened from the host?
Oh, it might be. Hang on one sec. Let's just see.
Okay.
We might have just lost for 1 sec, but it should pull back up in a second.
Okay.
Okay, should be back. Is it back?
There it is. Yep, it's
Okay,
back.
great. Sorry about that.
So basically, solar thermal is very different from PV in that we use the sun's energy to generate heat rather than electricity. So at its core, it's distinctly different. It's not generating electricity, and basically what you get with solar thermal is thermal energy, and of course that has to be used for thermal applications. So in some ways it's less versatile than photovoltaic, which of course electricity can be used for many different applications. But there's also a lot of things you can do with thermal energy. There's some benefits to looking at solar thermal and using the sun's energy generate heat rather than electricity. One of the biggest is that it's just a far more efficient conversion process. Solar thermal panels generally operate well above 50% efficiency, which is more than double even the best PV panels in terms of converting the sun's energy into useful energy for an application. Efficiencies can go up as high as 80–90% for solar thermal applications, and it really comes down to operating temperatures and the type of application that you have. So typically solar thermal is used for domestic hot water. It can be used for space heating, radiant floor type space heating systems with or without heat pumps, outdoor ice melting. And as we'll see later in our presentation, one of our projects, we're actually using it also for dissipating heat, dissipating waste heat at night through your roof. So having an active thermal roof has a lot of benefits. And of course, PV is, it's an electrical technology. So basically you can tie that to the grid and offset electricity use for anything, whether it be lighting, electronics, appliances, or heating for that matter. Any questions there about solar thermal versus photovoltaic?
I
I
think
guess
we'll
we don't
have,
have a live audience actually, so.
I think we'll wait till the end and we'll do all the questions because folks will submit their questions via the questions box in writing, and then at the end I'll just run through them all.
Understood. Okay, thanks. Next slide, please. Okay, so some of the benefits of InRoof. InRoof really has a very unique product. It's unique in the market. There really is no other company doing what we're doing. There are many solar thermal companies out there making solar thermal panels that go on a roof. But as far as a truly integrated roofing product, we stand out far and above anything else out there on the market in terms of efficiency and maturity of the product. You can see a few pictures there on the right of some installations using the InRoof thermal system. So it's basically an invisible solar thermal system. We like to say it, put your roof to work. You take a conventional metal roof and it over time will not only pay for itself, but more than, many times over pay for the cost of the roof by delivering energy to the house. Obviously, it looks great. It looks like any other metal roofing product out there. And it's completely in-house design and manufacture. It's all done in the US and Massachusetts. Next slide, please. So here's just a little background on the company. You can see sort of the nature of the product there. We actually have a facility in Massachusetts where we can roll and manufacture the metal roofing panels, just like a metal roofer would. In the same shop, we can then build our solar thermal system onto the back of those panels. So that would be that lower left figure. Basically, what's delivered to the job site is a modular roof panel that can be integrated right into a metal roof. It needs to be designed accordingly. It's not just, it's a little thicker than a conventional metal roof. So there are some design changes that take place on the roof, but very minimal. And there on the right is an active system where you can see, one of the benefits of metal roofing, of course, is that it can shed snow and get to work very quickly in the wintertime. This type, the process that we've implemented in the design is highly efficient compared to any other roof integrated product. Most of them have sort of left the market and doing very little, but this is very efficient. We've got all aluminum components, direct contact with the thermal fluid flowing right through the roof. So you get a very, very efficient transfer of heat from the roof into where you need it. Yeah, I think we're ready for the next slide. Okay, so we've actually had two projects in partnership with MassCEC. The first started in 2016. It was an Innovate Mass project that was basically bringing our product out into sort of a commercial marketplace. It was when we were just coming out of a very rigorous testing and design phase. So this project sort of helped us get into sort of the commercial space a little better. We'll have individual slides on each project, but it's basically a small commercial project that's used for space heating. The second one was more of a research project in 2019, and it was basically evaluating the performance of our metal roofs for rejecting heat to the night sky. So it basically was taking your roof, not only using it to gain energy when you want to have heat, but also to reject waste heat in a more efficient way to improve efficiency of heat pumps and technologies that generate heat that is not useful. So we'll have a slide on each of these. We can go to the next slide. Okay, so this is the Innovate Mass project. This is a lumber yard and hardware store in Salisbury, Massachusetts. It's a little over 13,000 square foot facility, I guess you would say. It's basically a store, store front and offices. We've got 51 solar thermal panels there, and it's not the entire roof in this case, it's just a little subset of the roof. This was a customer that needed to replace their roof anyway, so they were prepared to invest in a new roof, which is really ideal for in-roof applications, because if you're going to be buying a roof to begin with, adding on the solar thermal the economics are, of course, even better in that situation. So this was actually tied to a heat pump. And so we call it a solar source heat pump. We're taking energy from the sun. Even in the middle of winter, we can do that very efficiently, putting it into some sort of a storage. In this case, it's a relatively small storage tank. And then the heat pump operates its cold side. If you think of a geothermal heat pump, this is the side of the heat pump that would be down in the ground. And it then takes that energy, which is basically thermal energy, but at a relatively low temperature. So heat pumps can operate very efficiently at 60 degrees Fahrenheit or lower. And in the wintertime, that's not that hard to achieve compared to trying to get, say, 120 for domestic water. We don't have to get nearly that hot with systems like this. So we can operate at low temperatures very efficiently. And the plot there, the heating and cooling costs, we monitored it for an entire year and found that the heat pump that we had operating, the solar sourced heat pump, was the lowest cost form of thermal energy, and that includes geothermal and natural gas furnace heat. So basically, by providing a nice thermal source to that heat pump from the sun, from the roof, we brought the efficiency of that heat pump up well above a typical geothermal, and to the point where the cost of delivering heat to that building is actually lower than even natural gas, which is fairly hard to do in the thermal industry. That's kind of the target, and we did reach it. Of course, there's upfront costs, but there's situations, of course, where natural gas is not even available. But when you can get your heating costs to a point below natural gas, you're doing very well. Next slide. Thank you. Okay, the second project with MassCEC was the Catalyst project. And that was the one where we were actually doing more of a research type project. For a year, we measured how much heat can we basically radiate out of our rooftop in the summer months, so that we could, at times when you don't need thermal heat or applications where you don't need the heat, you can also use your roof to dissipate and get rid of waste heat. There's some advantages to this. One, most of that heat is being radiated right into space, right into the night sky. So you're actually removing heat from the warming globe, the global warming problem. Of course, it's also using your active envelope of the building for energy use, which any other roof is not actively doing. And what we found, we ran tests for an entire summer, both in Massachusetts and in Santa Fe, New Mexico. And we found that local site conditions didn't actually make a whole lot of difference. What really mattered was your operating temperature, which was not a surprise. But we found there that the plot there is basically showing that you can get between about 2 and even up to 6 tons of cooling from your roof, depending on your operating temperature. So when you have waste heat, if that temperature is 30 degrees above ambient, you can achieve about 4 tons of cooling with a typical residential roof, which in this case would be 750 square feet. So we basically were testing a new and innovative application here and found that, yes, we can definitely dump waste heat right out of the roof, using the very same roof that can collect heat in the winter months. So it basically just adds potential new markets, new customers, and value to those places that have both a heating and cooling season if you want to truly integrate your building and your roof into your heating and cooling system. We can go to the next slide. Okay, so this is just kind of a little case study of a residential installation. This is in Amesbury, Massachusetts. It's approximately 2,200 square foot home. I think, correct me if I'm wrong, Fred, but it's roughly 600 square feet. Is that right, the roof?
A little less, about 400 actually.
Oh, okay, about 400 square feet. It provides space heating, solar hot water, and the system also has a heat pump and can do radiant cooling. So this is a system that's been installed for several years. And maybe Fred, being that you know a lot about this system, maybe you want to make a few comments here.
Yes, I just left there a little while ago actually, and the clouds were coming over, but the roof temperature was about 130 degrees right now, which for a 70-degree day. So at this point, it's operating. It's doing domestic hot water heating. We've just been doing space heating with it, and but coincidentally, about 3 months ago, the boiler failed on us, so we've been operating 100% solar for the last 3 months. I don't think it would get us through. I don't think the system is big enough to get through January or December, but at this time of year, it was working very well for all of the space heating. And then in another month or so, we'll be going into cooling season, and we'll be running the system in reverse, and we still will collect the heat for domestic hot water, but there will be days when it's too hot and we want to get rid of heat out of the house, so we'll be rejecting it back up through the roof. And so this is an interesting time because we're probably gonna we've had an oil-fired boiler in there, and it's just an old system that I always wanted to get rid of anyway. But now that it's gone, now that it's actually broken, we're probably going to switch over to a geothermal backup system, so it will have the benefit of the solar thermal. And when the solar thermal is depleted, we can go to a smaller geothermal backup system. Since the geothermal works on the same heat pump, all we have to do is add a borehole to make the system complete with geothermal plus solar. So that's essentially how that works.
Great. Okay, the next slide. Okay, so this is just kind of a table of the products that InRoof Solar currently provides.
Excuse me, Bill, maybe you want to speak to this?
Sure, thanks, Fred. So yeah, we've got a lineup of 4 products that are the primary things we're bringing to the market. Our Marathon product is, a basic metal roof, long-term durability that we actually make in Amesbury at the shop. The Temp Keeper, we add insulation, and so we can help homeowner reduce their energy costs just by insulating the roof, either for the first time or to add more insulation to the roof. And then the Nor'easter product, we integrate the solar thermal feature that John's been talking about, where we can either add heat in the wintertime or reject heat in the summertime, as Fred was talking about. And then the power plane option can go on any of the other 3 products, and it's a thin film photovoltaic that we use because it only has a small reduction in the heat transfer. But we can get some electricity off the roof as well with a low profile kind of look, which architects and some homeowners prefer versus the big plates. So that's kind of our lineup right now. And as you can see, and I think, John, you did a lot of this work, the Nor'easter actually is rated, went through extensive testing, and we have a rating which we believe is very valuable in the marketplace.
Yeah, that's the SRCC rating, which is really tied to pretty much all of the incentive programs around the country. So once you have that, you can apply directly for the tax incentives, and all the most of the local and state level incentives also require SRCC certification. Yeah, I think we're ready for the next slide. Okay, so this is kind of just what we are, sort of our business model, how we operate. Maybe, I don't know, would you want to go through this one, Fred? This is sort of how we go from customer to project, I guess.
Yeah, actually, this is probably Bill's area.
Maybe Bill should do this, yeah.
Bill.
Okay, thanks. Yeah, we've been working with a number of clients, and of course, the first thing we need to find out is that since metal roofs cost more than asphalt, customers have to look at the upfront capital costs of the metal roofing, and this can be offset with federal and state tax breaks and incentives, but it is a capital burden that has to be considered. Once we kind of go through that estimating function and make sure it's kind of in the budget for somebody, then between online resources and building plans we might get from a customer, we can go through and do a pretty detailed analysis of the roofing area, look at the orientation of the house and the roofs, figure out which product may make the most sense in the different sections of the roof, and then work up a quote that includes not only the costs of the products, but also the performance. And that's everywhere from how many BTUs we can take from the sun and deliver down to the heating system, as well as how many watts of power we can generate off the photovoltaic systems up on the roof. So once the basic design is done, then we can keep refining it, which is step 3. Step 4, we get the estimate all integrated with the building contractor, maybe some heating subs for the HVAC system. Final details are put together, and then the product is made and delivered. We refer our customers on our website. We have a lot of the information for tax credits and subsidies so that they can easily find all that stuff through our website. And this package has been pretty attractive for us, and people have been able to benefit from it. So thank you.
All right, yeah, I think we can go to the next slide. Okay, yeah, so this is basically just sort of a business trajectory showing sort of the evolution of the company and the product. It really started early on with a lot of rigorous testing, including third-party testing. We did a lot of testing at the Florida Solar Energy Center early on, which is one of the test labs that basically is used in the industry. They're no longer open, as it turns out, but at the time they were probably the primary solar thermal test lab in the industry for certifying solar thermal products. So InRoof went there to basically work on the design and characterize it and optimize it before it really went to market. Then the company was founded. We went through the certification process. We had advanced our manufacturing capabilities, and now we've been kind of doing more advanced research on different applications, including solar thermal, tide grid, heat pump tied systems. And really where we want to be is industry leaders in building integrated solar heating and cooling. And we think it's a really nice fit to use the building envelope as part of the HVAC system. It basically brings the building to life and lets it interact with the environment in ways that really help the efficiency of the building. Next slide. Okay, so this is the team. This slide was made without Bill's picture in there, so Bill ought to be in this as well, but this is sort of the original team, I guess. This was taken a couple years ago, so we've expanded a little since then, but just to put some names to faces, we included this. Okay, next slide. All right, that's it. If anyone has any questions, or if you want to, any further details, we're happy to answer.
Great. Thank you very much. This was a very interesting presentation, and it's great to hear how everything progressed from your earlier Innovate project through your more research kind of new adventure under Catalyst, and we were glad to be able to support both efforts. So we do have a couple of questions from the audience here. I will one more time just remind anyone who is on the line, if they want to ask a question, to please submit it in the questions box, and I will ask them on your behalf. So we'll jump right into it. A couple of questions on the technology. So one was, what is the coefficient of performance, or the COP, for the in-roof heat pump that you mentioned earlier?
Okay. Do you want to take that one, Fred, or?
Sure. Yeah. So basically, the coefficient varies depending on what the average temperature of the storage system would be. So, and it also depends on what type of heat pump you're looking at. If it's an air source or a water-to-air heat pump or a water-to-water heat pump, that will change the coefficient of performance. But generally speaking, we're looking at about 5+ per COP. So air source heat pumps, John, what would you say?
The air source are, direct air source, even though they get a lot of press, and for good reason, but they often have a hard time reaching 3, especially in the really coldest months. Geothermal, I think, are typically 3.5 to 4, maybe a little over 4, depending on conditions. Those are kind of typical numbers, I guess.
Okay, great, thank you.
Sure. Yeah.
I was
just going to say the project where we monitored for a year, we had COP of roughly 4.3 to 4.5, but that system was really not optimized for heat pump use because of the size of the storage. It was designed as sort of a retrofit, so we could definitely do better than that. Well, 5+ is very achievable over the course of an entire season.
Got it. That's great. Those are good numbers. It's nice to hear. And do you have any estimates for the cost of the roof? I mean, I imagine it probably depends on the size and things like that, but just a ballpark figure, maybe per square foot, or however you're thinking about pricing.
Right, we've been putting that together, and basically for the just the insulated roof, it will range anywhere from $20 a square foot. If you add all the bells and whistles, including the photovoltaics, you can get up to about $60 a square foot.
Okay, great, thank you. Does your roof that you put on, does that add an added load on the home for cooling the home during a summer day? Is there any added load for that?
No, actually, it reduces the load by insulating the roof.
Yeah, directly beneath that aluminum roof is 2 inches, 1.5 to 2 inches of foam insulation. So it basically, it sort of decouples the roof a little more, if anything. We get the heat through the working fluid, not through the roof shell, I guess. So yeah, it would actually not add any heat load because it's it's insulated right beneath those metal panels.
Case in point, there was one we did up on an island in Maine last year, and they have a unheated attic space, but now it's an insulated metal roof, so the attic space now stays much more neutral than it did before. It used to be unbearably hot up there in the summer, and now it's fairly cool in the summer up in the attic, and also a little bit warmer in the wintertime. So it works by itself. So for a lot of people, they may not have good solar exposure, and so we think that the insulated roof is probably the best way to re-roof.
Great, thank you very much. So one question came up about, I think earlier, Joe, I think it was you had the comparison against solar PV, and of course you asked if there were any questions. So there is one about that, so kind of jump back to that. you had a very interesting presentation. This person cited in their question as well, so I wanted to pass that along. Could you elaborate a little bit more on how InRoof Solar is different or competes with or doesn't compete with competitive solar panels?
You mean like with the photovoltaic?
I think that's, I would assume that's what the question means is solar PV, yeah.
Yeah, well, I guess with any solar, sometimes there can be a little competition for roof space. I think when it comes to thermal applications, if you're going to look at heating and cooling, in-roof solar makes a lot of sense to use that on your roof space. And of course, with the thin film, you can get PV as well. Naturally, if you were to put a conventional racked PV system over an in-roof, it would shade it and basically negate the value of the thermal aspect of that roof. So in that sense, there could be a little competition for roof space, but we also love PV. We like to say, if you're really ambitious, do a ground-mounted PV system and put the in-roof on your roof.
Or the thin film is another good way to do it too.
Yeah, or you can combine them. So we don't really see it as competing, with the conventional PV industry. Of course, when there's very limited roof space, the typical PV panels don't work directly over ours. You'd need to use the thin film, but that is a PV, it is also a PV roof at that point. So I don't know if that really answers the question. Does anybody else want to add to that?
Yeah, I think PV is our friend, not our enemy.
Yeah.
Yeah, I don't know if the question was related to the efficiencies, but we're working with the thin film manufacturer, and I would say right now the conversion efficiency of sunlight is about half with the thin film versus a panel. But the efficiency of this thin film is expected to improve fairly dramatically over the next few years. But of course, so are the plate technologies. So anyway, that just gives you a rough ballpark in terms of efficiencies, I guess.
Yeah, and this question is kind of follow up for me. So, from what I'm understanding too, obviously solar PV and solar thermal roofs are two different types of load for the home, right? Electricity versus heating. Have you formed any partnerships or relationships with solar PV companies to kind of complement each other in like a business way, kind of a whole home solution? Look, you can get green electricity and also heating and cooling from us. Has that been anything in your radar?
We've had a few companies out there, but nothing's really solid at this point. Just companies there's one in our own building here that we've been talking with a little bit. But it's a lot of that is regional, so you have to kind of find people that work in that area.
Yeah, the thin film PV industry typically likes to, provide a product to work with metal roofs. Basically a peel and stick designed to fit in between the standing seams. So those products are automatically a very good fit for the in-roof. But yeah, as far as a direct, partnership, I'd say it's some things sort of simmering, but not really well developed, as Fred said.
Gotcha. Okay. And then there seems to be just just kidding. Two more questions. One just came in. One is specific to something that Fred mentioned earlier. It says, Fred mentioned that the system in Amesbury isn't large enough to do the entire building, but that you were thinking of putting in geothermal as backup. Would a larger in-roof be enough to provide all the heating needs, or would you kind of always look to have a backup, particularly for geothermal? Just wanted to circle back to that point. Looks like
You always will need some form of backup. You're going to have a period of time where this isn't going to be enough. Cloudy weather.
Oh, Fred, we're having a little bit of a hard time hearing you, unless that's just me, but it's some kind of background noise on your end.
Okay, I'm sorry.
Oh, that's better.
I would say that you are always going to want to have some backup. So for us, we think that electricity, whether it's on your own house or whether you buy it through the community solar program, is a great source. So that's why we want to use the same equipment as the heat pump for the whole thing, but it's going to be difficult to get 100% solar. Now, maybe on a super insulated house, but our particular house is an older house. We are renovating to improve it a little bit, but we get 100% out of it would be difficult.
Yeah, I think the sound is still a bit of an issue there, Fred. It was hard to hear, but
I don't know what's going on.
yeah, I don't know. I was just going to add that, there are certainly cases out there with solar thermal providing heat for the entire house. One of the problems there is, one, you need really large storage tanks. You need to be able to get a really big store of energy for those, cloudy weeks in the winter. And you also need to bring your temperatures up quite a bit higher. And when you do that, your efficiencies go down. So ideally, what we really like to do is couple with a heat pump, which allows us to bring down the temperatures and the storage volume. And then you get that automatic, it's pretty easy to get a backup with a system like that incorporated. So of course, that house only had 400 square feet, and that's in Massachusetts. So, of course, you could add more and get more out of your solar, but it's not really something we try to do to get 100% solar heating.
Great, thank you. And looks like just one final question. What did you learn from trying your product out in Arizona, the Arizona project you talked about a little bit?
Oh, well, that was actually New Mexico.
Oh, New Mexico, right, okay.
Yeah, no, that's okay. Where the test took place, it was in Santa Fe, which is 7,000 feet above sea level. So you're basically at a very sort of a high desert environment. We learned a few things. Interestingly, that was the night sky application. So we weren't running it during the day. But we were seeing some really, really useful temperatures during the day. Of course, even though the temperatures don't get that hot because of the elevation, the really clear sort of atmosphere and the sunny skies, we were able to get higher temperatures above ambient in that environment, though not significantly. But we also really learned that what mattered even more than the local conditions was just what's around your roof. Just like with solar during the daytime, you look for shading issues, maybe orientation, basically anything that obstructs your view of the sun or your sort of optimum view. The project in Santa Fe had not quite optimum orientation, and it also had trees surrounding the site, not blocking the sky necessarily, but showing part of the view. And at nighttime, we learned that those trees are quite a bit warmer than the night sky. So the energy balance was such that even with a nice clear desert night sky, if you have obstructions even at ground level that interact with your system, that can contribute to how much heat you can actually dump. So if you had real apples to apples, you would do a little better, I think, for heat rejection in the sort of higher altitude, clearer, sort of desert night sky. But it's not as big a difference as you might expect. And for any location, you can get a very usable system. And if you focus more on just the good installation, location, and orientation, that was really the bigger factor than the two climates.
Yeah, to add to that, I would say that the heat rejection is more diffuse, so it looks at the whole sky, whereas when you're collecting energy, it's more direct. It's the beams are coming straight from the sun. They're not bouncing off. They are to some extent bouncing off other things, but it's mostly just the direct. So it's a much more defined sort of shadow line from direct light than there is in the reverse direction. We actually took infrared cameras and took pictures of the trees at night, and you can see them glowing. It's quite phenomenal to see.
Yeah,
Yeah, there's a lot
that
of
was
heat
cool
there.
to see. Great. Well, we don't have any more questions from the audience. Thank you for indulging all the questions. And of course, thank you for your hard work on both these projects with MassCEC. It's great to hear the results and to wrap things up. And we wish you the best of luck.
Thank you.
Thanks, everybody.
Thank you very much. Have a good one.
You too.
And thank
Bye-bye.
you everyone who joined us today from the audience. We appreciate your time and questions.
Thanks.